Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today we are going to discuss about the topic isolator. This topic is comes under the unit microwave passive devices. So let's see the topic. So, what is actually an isolator? So, isolator is a non-reciprocal device that allows light to pass along a fiber in one direction and offers very high attenuation in the opposite direction. So, this is called a isolator. So, isolator, which has one port, which is a very, offers a very high attenuation in opposite direction. So, one side is a non-reciprocal device. So, isolator are needed in the optical system to prevent unwanted reflections coming back down a fiber and disrupting the operation of the laser. Thus, it is producing noise. In manufacturing isolators, Faraday's effect is used, which is polarization dependent. So this is the isolator. So what we have discussed in the previous slide, this is which is shown in this slide as a diagram. So here in the forward direction, polarization filter is there. That is a vertical manner, and Faraday rotator is there, and polarization filter rotated 45-degree. And we have electrical field direction and electric field direction is there. Okay, so this is the forward direction. When it comes to the reverse direction, we have electric field direction, and this electric field direction is there, but it is a in the name itself it is a reverse direction. So the output is comes to the input side, that is mentioned in the arrow mark. So difference between forward direction and reverse direction is mentioned by the arrow marks in this diagram. So isolators are constructed using optical polarizer, analyzers, and Faraday rotator. The optical signal passes through the polarizer oriented parallel to the incoming state of the polarization. Faraday's rotator will rotate the polarization of optical signal by 45-degree. So here you can see the isolator diagram. See the port 1 and port 2, port 3 is mentioned. So port 3 is terminated and port 1 and port 2 is there. So according to the statement, so parallel to the incoming state of the polarization, so Faraday rotator will rotate the polarization of optical signal by 45-degree. 45-degree polarization will take place in this case. So let's take up the classroom activity. So just look at the diagram image which is shown in the slide and find out the answer. So the group of team members you discuss and find out the answer for this rebus puzzles. Then key features of isolator. So some of the key features of isolator is mentioned over here. The first thing is unidirectional signal transmission. That is ensures that the signal travels in only one direction. Then isolation provides high isolation. That means it's called as a attenuation to prevent reflected signals from interfering with the source. Then next one, low insertion loss, that is minimal power loss for signals traveling in the forward direction. Then what is high reverse attenuation? Strong suppression of signals traveling in the direction is called a high reverse attenuation. So these are all the some features. And the next thing is types of isolators. So what are the types? So first thing, ferrite isolator is there. Another one is a resistive isolator. Below the ferrite isolator, we have used ferrite materials and an external magnetic field, and the non-reciprocal behavior is achieved through a Faraday's rotation effect. Then resistive isolator employ resistive material for isolation, simpler and less expensive, but have higher insertion loss compared to ferrite isolators. Then, when it comes to the applications, so it has several applications. So it is here the only the very few important application is mentioned over here. The first thing is protection of microwave sources. So prevents damage from reflected power, especially in amplifiers and oscillators. Then improvement of stability ensures the reflected signals do not affect the performance of source components. Then integration in measurement setups used in the test and measurement setups to maintain signal integrity. So let's take the assessment. The first question is, what is isolator? The next question, what is ferrite isolator? The next, what is the resistive isolator? List the advantages of isolators. List the applications of isolators. Thank you.